Let's take a look at example 5. In example 5, we want to find all the zeros of f of x equals x to the fourth minus 6x squared minus 8x plus 24. So we're going to start by using the rational zeros theorem. Let's write out the first term, the constant term, and the leading term. So those are 24 and 1. The next thing we're going to do is list all of the different factors of those numbers. The factors of the constant term 24 would be 1, 2, 3, 4, 6, 8, 12, and 24. The factors of 1 are just going to be 1 itself. So according to the rational zeros theorem, the potential possibilities for rational zeros are going to be plus or minus 1 over 1, which is just 1, plus or minus 2 over 1, which is just 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 8, plus or minus 12, and plus or minus 24. Let's now go ahead to test to see if any of these is a zero. Let's start with positive 1. Now be very careful here. This is something that came up in the last section, but when we want to do synthetic division, make sure you write out your dividend polynomial with all of the coefficients in decreasing order. Notice that this polynomial does not have an x cubed term, so if it's 0x cubed, we do need to put that 0 in our line over here. So x to the fourth, x cubed's coefficient, then we have x squared's coefficient, then x, and then our constant term. Let's begin. We bring the first one comes straight down. Bottom times block gives us 1. Add to go down. Bottom times block gives us positive 1. Add to go down, we get negative 5. Bottom times block gives us negative 5. Add to go down, we get negative 13. Bottom times block gives us negative 13. Add to go down, we get positive 11. So this shows that positive 1 is not going to be a rational zero for the polynomial. Let's try the next positive value, which would be 2. So first one comes down, so we have 1. 1 times 2 is 2. Add to go down, we get 2. 2 times 2 is 4. Add to go down, we get negative 2. 2 times negative 2 is negative 4. Add to go down, we get negative 12. And then 2 times negative 12 will give us negative 24. Add to go down, and we do get 0. So what that tells us is that 2 is a rational zero for the polynomial x to the fourth minus 6x squared minus 8x plus 24. So we found one zero, and it's going to be x equals to 2. We can continue this to find the additional zeros. So we have a partial factorization right now from that 0. If x equals to 2 is a zero of the function f, then that means that x minus 2 would be a factor. So we are able to write f of x as x minus 2, and then this would be our quotient. Remember, it starts with a going from right to left constant, x squared, x cubed. So we would have x cubed plus 2x squared minus 2x minus 12 right now. To find the remaining zeros, we want to work with this piece here. And so now this will be the part that we're going to perform synthetic division on. Keep in mind that if positive 1 wasn't a zero of the original function, then it's not going to be a zero of this subpiece either. And where we left off, we were testing x equals to 2. It's possible that a particular value might occur as a zero more than once. So the moment we know that 2 works, let's try 2 again, just to see if maybe it happens again. The 1 comes straight down. 2 times 1 is 2. Add to go down, we get 4. 2 times 4 is 8. Add to go down, we get 6. 2 times 6 is 12. Add to go down, we get 0. So it turns out that 2 is a solution again. So right now we can factor f of x if you're keeping track of the factorization. This is x minus 2. You have another factor of x minus 2. And the quotient is this x squared plus 4x plus 6. Okay. Or of course, you can write this in exponential notation. But so far we have the 1, 0, which is repeated. X equals to 2 has multiplicity 2. And then to find the remaining zeros, it just resorts to solving where x squared plus 4x plus 6 equals to 0. And this is a quadratic, so we can solve this with our method of quadratics. This won't factor, unfortunately, but we can use the quadratic formula. A is 1, B is 4, and C is 6. So let's go ahead and plug those in. It's going to be x equals negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. This is going to be negative 4 plus or minus the square root of, this is going to be 16 minus 24. 16 minus 24 is negative 8, all divided by 2. That numerator, if you look at that radical, that simplifies. It's also going to be imaginary. That reduces to plus or minus 2i radical 2 over 2, which itself reduces to negative 2 plus or minus I square root of 2. So we started with a polynomial of degree 4, and we actually do get 4 complex valued solutions, as is stated by the fundamental theorem of algebra. So all the solutions are this. We have x equals to 2, which is a solution that has multiplicity 2. We have 2 complex conjugate solutions. They are negative 2 minus I radical 2 and negative 2 plus I radical 2. Again, with the rational zeros theorem, synthetic division, we are very easily able to pick off the rational roots and eventually keep working until we get down to a quadratic. And then once you're there, you can solve it via any method. If it's factorable, you can factor it. If not, just plug it into the quadratic formula to find the remaining roots of your polynomial.